All right, I'm going to show how this astrocyte transit calculator is used. So this is the GUI interface here. And in the back, this is in Python, so in the background it prints out some diagnostics to the screen. The first field is the latitude of the location that you're going to be viewing from. And then the second one is the longitude. This is a signed degree, floating point signed degree. So don't enter, it won't allow you to enter north south, so you need to, for south and latitude you need to enter negative, and for west and longitude you need to enter negative. So this current location that's set here is the location of ICNS. The next field is the when you want to start searching. So and this is in UTC time. If you want to use your local time, you can do that by clicking on one of these clocks here, which will open up a dialog, and then you can enter your local time, and you can choose your local time from this list. There's only Australian times in there now, so in the future, if someone else wants to use it outside of Australia, then we'll need to update those. So I've selected 5:30 p.m. in the evening on October 1st, and if you click done, it calculates the UTC time for you and then puts it in that box. It's it's year, month, day, hour, minute. I don't want to go any more fine-grained than minute. The next box here is a combo box where you can select which satellites or resident space objects you want to look for. The list is kept in a file in the local directory, which you can update, and I'll show you how to do that in a moment. Most of these, all of these actually in this list presently are from Celestrack. So you can click, you can search all of the objects that are available, the Bryce 100, you can look at Starlink satellites, CubeSats, Active Geo, etc. If there's something in this list that you want to look for that isn't present, then you can click on this button and then you can add a list. For example, in here, I say my TLE list. This is the name that will be put into the combo box. And then in the next field, you enter the source location. The source location has to be either a local directory path, so the full path of a local directory. For example, /my directory /my TLE list.txt, or something like this, which is a Celestrack URL to a TLE list. It's always going to be a text file. If you don't put the text, it'll load it, but the code assumes that you've got a properly formatted TLE list. I don't want to actually put that in, so I'm going to hit escape. The next combo box is the object for which you want to search transiting resonant space objects. You can select any of these objects. Most other objects in the solar system are going to be too small to be able to probably actually find something that goes in front of it. So I've got the Moon, Sun, Mars, Venus, Jupiter. If you select none, then that means you're searching for objects that are a certain angle away from zenith. So if you want to search for what you can see during that particular time period, given your location, you'll use none. For this demonstration, I searched for objects which transit the Moon. So when you will have to look up manually what the angular size of these objects are. The Moon's about ½ a degree. So the next parameter is the angular radius from the center of the object that you want to search for transiting resonant space objects. So this is the object you're looking at, and then you want to see if any satellites transit this. I put in 1/4 of a degree here because the Moon is about ½ a degree in diameter, which is equivalent to about 1/4 of a degree in radius. If you want a note about when you put in none, so if you want to look for things that are just available in the sky, then you put none, and then this number will be the angular radius that you're searching for from zenith. So it's 90 degrees different from the altitude. So for example, if you wanted to find all satellites which were 10 degrees above the horizon in altitude, in this box you would have to put 80 degrees because you're searching 80 degrees, around 80 degrees from zenith to find all of the objects that are 10 degrees from the horizon. And finally, when you filled all of these out, you can click on Update RSO Lists, and it will take a while. It will propagate these lists of candidate satellites for those time periods. I've improved the search algorithm, made it about 10 to 20 times faster than it was, but it could probably still use some improvement, but it's usable right now. Once the search algorithm has completed, it will propagate these lists, and then you can click on one of these and it will show you the specific starting, peak, and ending times for the transit of your object. For example, this Starlink satellite, 1422, and these times are in UTC, so you have to convert them back to your local time if you need to know that for your local time. So this one, for about 9 seconds, transits the moon at about 5:53 in the evening in local time. All right, if you have any questions, get in touch with me.